Hi, I'm Ranger Dew with the Health and Life Services team at Cloud Solutions Architect. Today we're going to be talking about designing application storage and data access strategy. So to talk a little bit about a course overview, we're going to be talking first about designing data storage. This is kind of 101 for how Azure uses data storage. Then we'll be talking about applications that use mobile services, then notifications, applications that use web API, strategies for hybrid applications, and finally, media solutions. So let's talk about designing data strategy first. This slide was back from October of 2011, but it's still valid today. If you notice on this slide, you'll see that at the very bottom layer, at the stream layer, we've got a distributed replication. That happens across the entire Azure platform. Partition layer, we do load balancing and automatic index layering. But the part that's more interesting and the part that we're going to talk about today is going to be that top layer, that front end. It's really just abstraction of blobs and disks, tables, queues, and file sharing. So what do? The first thing you do is you're going to go in and start from your EA, you're going to create a subscription. Once you end that subscription, you're going to create something called a storage account. Now, the storage account is really going to be a blob, or it's going to be a table, a queue, or files or directories. There's some limitations on storage accounts. One of the limitations is that there are 20,000 IOPS. Now, we did that per storage account, but you can have multiple storage accounts and stripe across them if you choose to. Each storage account can have over 500 terabytes. Now, these numbers change often, so as you're preparing for the 534 exam, I suggest you go in and look for the performance measurements and see what they are at that time. First, let's talk about abstraction of blobs. Blobs are massively massively scaled object storage in the cloud. They have a REST interface to them, and they're good for things like data sharing, pictures, that kind of thing. I've got a little bit of code at the bottom that will go in, connect to a storage account, and allow you to just add in information into your blob or pull things out of the blob. The next abstraction that we're going to talk about is disks. Disks are basically persistent disks for VM storage in Azure. They're stored in page blobs. Page blobs are maximized for the maximum amount of random I/O. So unlike other streams, which may be more sequential, if you're going to have any kind of random I/O, you're going to want to use these. Now, I've got a little bit of code at the bottom here that tells you how to access them if you're interested. Recently, we announced premium storage. The number of IOPS per disk was a problem for many people. With premium storage, though, there's a consistently lower latency. They use SSD drives, and they're suitable for very high IOP situations. They support up to 1 terabyte in size, and you can stripe them. So we're talking more than 50,000 IOPS if you have it striped. So premium storage works in conjunction with the new G series. Another type of abstraction that we can talk about are tables. Tables are basically massively scalable, NoSQL cloud stores. By NoSQL, I mean that they basically have a key value pair, and you can store anything in the value. It auto load balances in order to meet your trafficking needs, and there's several different protocols, including OData and JSON, that are very popular. The piece of code down at the bottom kind of shows you how to access those pieces of storage if you need to. Finally, there are queues. The thing I like about queues is that queues enable the applications to be loosely coupled. So as we talk about the benefits of the cloud to our clients, and as you're taking your 534 exam, you're going to be faced with a few situations, and these situations may ask you, how do you decouple things? Well, queues are usually used for that. It's very important that you understand that, and I've got some code at the bottom that will allow you to add messages to queues. Finally, another type of abstraction is called a file. Files are basically great for moving on-premise applications up to the cloud. And the reason for this is that files are mostly SMB 2.1 protocol compliant. What I mean by mostly is it supports most of the protocol that you would expect it to use. So if you're looking at moving something from something that's on premises and you just want to do a lift and shift to the cloud, files are probably what you want to use. There's a lot of additional services, tools, and libraries that come with Microsoft Azure. One of the most important tools, and the one that I'd like to point out here, is that for customers that have large amounts of data, it's just not practical to ship that over the internet. So we do have a service where you can take your drive that's terabytes large or several drives and ship them to Microsoft, and we'll put them into Blobs for you. Now, Brett, you're probably wondering, but what about concurrency?
What about concurrency, Ranger?
Well, that's a great question, because as more people try to write to these things, you have to have some concurrent mechanisms. So as you can see on this slide, we've got both optimistic, pessimistic, and last write wins concurrency for Blobs. You get to choose which one you use. By default, last write wins will be the one that's created in a blob. For table storage, it uses optimistic concurrency. File service uses both REST, and the default is last wins, or you can get to it through SMB file system. Now, there's a lot of scalability targets that you might find. Again, we had some that we talked about, for example, for the storage account. The storage account itself has a 500 terabyte limit. That's an aggregate. So if you have blob storage and you have queues, the aggregate amount of that can't exceed 500 terabytes. Similarly, the IOPS that's for the aggregate can't exceed 20,000 IOPS. So if you know that you have some queues that may be high transaction rates, and you're worried about the IOPS, you can put these into another storage account to get higher IOPS. One thing I would like to point out on this particular slide is that we have new bandwidth restrictions as well. With geo-redundant storage, you'll get 10 gigabytes per second ingress and egress at 20 gigabytes per second. With locally redundant storage, that number is higher. With partition size presently, you can see what we have, but my suggestion is that you go out to Bing and look up Azure Storage Scalability and Perf targets to make sure that you understand what the limits are today. So with creating the storage account, you might ask yourself, how do we make sure that this thing is securitized? And being in the cloud, how do we give people access to it? There's two basic ways to give people access to the things that you create. The first way is through a proxy, and that's demonstrated in the first slide here. The second way is very interesting. It's through Windows using an SAS provider. Basically, your application goes out and gets authenticated through an SAS provider. It does a get, comes back, and at that point you have a key, and you can write to your Windows Azure storage. So if you look at the bottom here, you can see that this is one copied. What this URL has in it that allows access is both the storage resource, the start time, the expire time, and what permissions this particular URL has. So you can give this URL to someone, and they can have access to your particular blob storage device, and with all the restrictions that you provide. You can also give out your regular key, but I don't think you want to do that because that opens up permissions. There's a lot of different data storage options. In this slide, we've kind of outlined what they are. We've got relational, key value, column databases, document databases, the new one being DocumentDB, and graph. When you have storage, you have to worry about the durability of the storage. We have several different options for durability of storage. The first one is locally redundant storage, LRS. Basically, that stores 3 replicas of the data within a single zone or facility in a single region. Today, there are 15 regions. Geo-redundant storage provides more copies, 3 copies in each region, but it goes across regions. And finally, there's zone redundant storage, which goes across multiple zones. The price of these are different, and are different depending on what your business objective is in storage. One of the nice things about the geo-redundant is the ability to have secondary read-only access. So if you choose geo-redundant storage, you can opt to have the read-only access that will allow you to, from a secondary tenant, to be able to go in and use that endpoint to read particular things. The thing is, all the rights go to the primary, so it may take a second to be strongly consistent. There's 17 regions worldwide in 2015. You thought there wouldn't be a test, but there is. So, Brett, I hope you've been paying attention. Let's take the first test. A blob is a 1958 movie with a budget of about $110,000, a unit of storage in Azure that's encapsulated in a container. Blobs are good for streaming, backups, or sequential writes. Page blobs are good for random read and writes. Which of those is true?
I think they're all true.
That's correct, Brett. They're all true. Let's talk about tables. Table. Is it something you eat on? Is it organized in partitions and automatically load balanced? Does it use a key value NoSQL storage for large unstructured data? Or is it accessible by REST API, OData, and JSON?
Again, I think those are all true.
That's correct, Brett. They are all true. But here's one that'll get you. A queue. Is Q an entity with an omnipotent powers in a recent sci-fi show? Does a queue limit you to 64 kilobytes in size per message, but can contain as many messages as the storage count will allow it? Is it good for decoupling applications, or is it good for workflow applications?
I think you've set me up. These are all true, too.
Brett, you're amazing. They're all true. So file storage, finally the last one, and I think this one's an easy one. Are file storage a box where important papers are kept in my attic? The mostly SMB 2.1 compliant, used for VHDs like Azure Disk, or used for file sharing between Azure applications like Azure File Shares?
Again, these are all true.
They're all true. Thank you very much. So we've kind of been through the basics of what Azure Storage is. What we're going to talk about now is designing applications that use mobile services. Now, you're not going to need to know a great deal about the details of mobile services, but you are going to need to know the features and how they apply. So what are mobile services? Well, first, mobile services create applications that allow you to create applications for all devices, for iOS, Android, and MS. And they make your application work offline. You can use a single sign-on. You can have access to on-premises data. They're good for integration with different types of social media. And they provide analytics. So all of these things are involved in the umbrella that we call mobile services. I'm going to take one little scenario to kind of show you how this might be. On the right-hand side of this particular slide, you see what ports we need to open and why. You need to open port 80 for HTTP certification, 443 for HTTPS, and of course we need 5671 open, and we need 9352 open. If those ports aren't available, they'll try to use another port. In this particular situation, you can see that I've got some kind of mobile device. Now this mobile device could be a phone or some kind of tablet or phablet. You might want to use SQLite, which can be easily pulled out of Visual Studio and included in your application, such that you can have offline database that's stored locally. We use something called data transfer objects to get the data from the device to the mobile services platform. And there you'll have a table controller, and we'll use a feature called AutoMapper that will map the data transfer objects, which are in the particular format that you might need for your mobile device, into a data model that may already exist on site. So that's one scenario. Another scenario may be where you have an application and you've written a mobile application. You want direct access to your on-premise SQL Server. In that case, again, mobile services has features that can help you. It can make a call through port 1433 to the hybrid data connector that's on premise. And you can find it. I have a note here that you can find that hybrid data connector under BizTalk. You do have to install BizTalk, but you don't use all the features of BizTalk. And that hybrid data connector will allow you to talk to basically make that SQL call all the way through to your SQL Server database. So how does the authentication flow kind of work for mobile applications? So let's take the basic case first. You have a mobile device, and you want to authenticate. So the first thing that your device does, it uses Active Directory authentication library that comes with the mobile device, and it comes with Android and with iOS, and it sends some credentials which are sent to Active Directory or Azure Active Directory that returns an access token. At that point, the client presents that access token to mobile services. And when mobile services responds, you basically get a token back for a continued session. So what's happening during that response time? Well, what happens when you present that token is that mobile services goes out, they take that and it gets a client ID or client secret and sends back an access token that can be used to gain access to, for example, SharePoint. Very simple, I think, on mobile services. Let's talk about designing applications that use notification. Notification services is pretty interesting. In fact, in some areas, push notifications are transforming our businesses. We use them to push information to millions of customers. We use them to push notifications for exchange, maybe to your phone. Or you may have other notifications you may want to be pushed out, especially in the financial area, where a stock price hits a certain thing or a trade may occur and you want to push that out. So it's really for increased employee responsiveness and productivity. In the one industry that is adopting it very heavily is financial industry. They embrace multi-channels, they embrace smartphones, and the customer expects two-way communication. So not only do I receive a push notification, but I might want to respond to a push notification as well. They want to move off of text messaging. So the functionality that's included in push notifications is much richer than that. And it's also about 1,000 times cheaper. So how does the push notifications work? In this particular diagram, you can see that the first thing that has to happen is my client device goes on and it retrieves a handle from the platform notification service, as in one. The app passes the handle back to the back end, and then it's registered, and the back end uses that credentials for authentication. The back end maintains those handles to that device, and it maintains a logical mapping between the users and groups. For Azure notification hubs, if you think about a expanded version of push notifications, the same thing happens. The client app retrieves a handle from the platform notification services. The app passes the handle back to the back end, and it registers the handle. In this case, with the notification services, though, it's registering also a tag. So if you can think of a pub-sub model, it's saying this is the tag represents a logical user. When I want to send a notification, the back end will send a notification to logical groups of users using that particular hub tag. The notification hub delivers notification to the matching PNS, or matching users who are interested via the PNS. And again, it maintains the device handles the same way. So there's a lot of advantages in using the notification hubs. So one advantage is that it can backend almost any platform. So even though the backend is us, we can use the front end as an iOS, Android, a Windows Phone, Kindle. So it works on a lot of different devices. Another nice thing is that you don't have to store information on the back end about the front end. The front end is going to pass you information when it needs you to understand things and its interest in users or particular groups. You can work with logical groups and logical segments. So again, because it's a pub-sub model, if I want to send 1,000 notifications out, I can see who's interested in them, and I can send those out. Finally, you can personalize and localize things. So you can actually take a template, and when your application says I'm interested in something, it's passing a small little XML template to it, and that XML template gets filled out and passed back. So if I want to, for example, have something in Celsius, then my template can say I want this in Celsius. The backend responds in Celsius, where somebody else may want that to be in Spanish and in Fahrenheit. Finally, you can do large-scale multicasting. So if you, for example, want to notify all of the people in a particular, let's say you're having a weather event, and you want to notify everyone who has registered in a community, you could, in fact, use notification hubs to notify everyone at once. And finally, you get rich telemetry available through the APIs. You can get information about geolocation and things like that nature as well. In this example, we have a single user notification. The client app authenticates with the backend, it passes a device handle to the backend telling it who it is, and it registers the device for the tag user ID. So it's basically saying I want information. The targeted user specifies the particular user ID. When there's something, the notification hub simply responds. Another scenario that's very similar but different, but slightly different, is where you want a secure notification. In this particular case, you have a push-pull pattern. So it's the exact same scenario as the others. My client app goes out there, it authenticates with the back end, the client app passes the device handle to the back end, and it registers again exactly the same way. But in this situation, what I'm pushing back, what I'm going to push back is going to be a request that the client app then responds to on a secure channel. Here's a little piece of code that would trigger a synchronization, for example, if you wanted the synchronization to occur.
And this code would run in the back end?
This code would run on the front end.
Oh, front end, okay.
So basically,
to trigger a sync from the client back.
Exactly.
Got it.
So in this particular, here's a particular scenario where we want to broadcast to a segment based upon interest. So people are registering and saying, I'm interested in the tag Rolling Stones, for example. When the backend has some information about that or that's received, the notification hub says, well, who's interested at this point in the Rolling Stones or in the Beatles? And it's pushed to their machine based on the tag. In some situations, I may want to notify all users. So again, you can make a single API call from the back end. The notification hub says, okay, I'm going to notify everyone, and it's all pushed. Another scenario may be that I want to notify everyone with iOS that I'm going to be maybe updating their computer or something of that nature. So I might want to notify based on batches, based on device, based on particular users. For example, maybe I'm in a hospital setting and I want to update the physician's machines first, or I want to update the nurse's machines first. So I could update based on batches. And again, the notification hub will allow you to notify based on batches. So here's a scenario that we talked about earlier where you want to be both personalize and localize. In this case, what you're trying to do is make it more relevant to the person that is consuming the data. So language preferences, alerts, orders, deals, that kind of thing. So if you're in the financial institution, you want to notify a person that their bank account is low. So your application would register and would go through that kind of thing, saying I'm interested in these kind of tags. Or I could use push notifications for the same kind of thing. So the first thing that happens again, the client app registers. Only this time when they register, they're giving it a template. So if you can see on the code, they're passing back a code template saying, I want my temperature in Fahrenheit. So it's looking for a particular variable. Bob's phone, on the other hand, may say, I want it in Celsius. So it's something completely different. But it's coming from the device and being registered in the notification hub. When there's something to send, there's something to notify, including the temperatures, both of those temperatures are sent to the notification hub. But the notification hub then sends those temperatures in the format that is expected by the particular device when it passed it the template. Another scenario is geotargeting. Perhaps you want to be within a certain distance, for example. So in that particular case, if you're in a particular region, you might, or with a certain geo-accuracy, you might want to get that and send out advertisements of nearby things. So you can use tags for location-based pushes. Here's a good example of that. Next, designing applications that use Web API. This is going to overlap a little bit with what Brett's going to talk about in Module 5. So what kind of scenarios do we use for this? Well, there's really three basic categories of scenarios. Websites, cloud services where web roles may be ideal because there's different features of websites and web roles, and when you might want to use a virtual machine. So those three scenarios we have outlined in this deck, and you might want to take a look at it in case you see any of them again on the 534 exam. Websites and web roles have different capabilities. What I'd like to talk about a little bit is what it's like for a website when it first gets a request. So through the Azure Load Balancer, a request comes in for something into IIS and the application request router. So at this point, it goes out to the runtime database. Now, in the old days, IIS used to go out to an XML file, no longer does that, goes out to a runtime database. It determines that foo isn't there. It isn't aware of foo. So it goes out then to the requested web server where foo should reside and says, oh, is it up? No, it's not up. So the next thing we do is we go out and we provision the site. It comes up and we respond after the storage controller and the website is activated. In the case of a warm site, it's a little bit better. In that case, we have the same kind of thing. Goes out, a request made to the web server. Web server says, oh, I'm already up. I already know who it is. And so then it just responds with the website that it needs. Here's the back end of that if we looked at it from a little bit a broader perspective. We've got all kinds of different services that are working to ensure that we do things like auto scaling. So in the case where we have particular metrics that we're trying to change, it would determine those metrics based on the metering that's done, and it may or may not bring up another site if those metrics or triggers are met. There's some heuristics for auto scaling that I'd like to show you. Originally, the only heuristic was the CPU usage. But that caused a lot of problems because there were a lot of things beyond that could cause a CPU usage that bringing up another site wouldn't solve. So today we have other things like memory pressures, disk queue length. So if there's a queue out there, we can go. If it's greater, if the queue length is greater than X, then we're going to trigger. Or data that comes in and out of your application. Now, web jobs are these were introduced rather recently, and they talk generally about things that you want to scripts that you want to run on your websites at a point in time. So it's scheduled. In some case, we want to schedule these continually to run, and in some case, we want to schedule them once a month or weekly. If you schedule them to run continually, then your web job is going to run on all of the instances that are brought up. If you schedule them to run, for example, on daily, weekly, once, or right now, then it's going to run on one instance. Now, there's a lot of different acceptable file types or programs. They're listed here.
And these web jobs don't require a separate VM to be spun up and created.
No, they don't.
They're just part of the website.
That's right. So
Yeah,
what
nice.
determines whether or not where they're going to be run is only whether or not it's continuous or whether it's at a scheduled point in time.
Got it.
How do you secure your website? Brett's going to talk about this in a little bit more detail in 5. But basically, anytime that you have a website and you want to register, what's going to happen is you're going to register your website with Windows as your Active Directory. Then you're going to front end your application with Windows Identity Foundation. Now, today, there are templates out there. So if you go into Visual Studio, you'll find that there's all kinds of templates that you just click a button and it's done for you. When Windows Identity Foundation determines that it doesn't understand who you are, it'll redirect you to a sign-on page. The sign-on page will have you sign on to your Windows Active Directory tenant and pass back a token, and that token is given to Windows Identity Foundation to figure out who you are. Designing a data access strategy for hybrid applications. If you have a hybrid application, and by hybrid I mean that part of it's on-premise and part of it's off-premise, there are a few basic strategies that really will ensure that your application runs well and that you can get the telemetry you need in order to diagnose problems or in order to diagnose performance issues. So in this particular case, we're using the use of Azure Service Bus Relay. The Azure Service Bus Relay what it allows you to do is to make a web service call, basically, and that's relayed through to your on-premise application. So my application at my client, whatever it happens to be, will make a request through the service bus. It'll go through my firewall and go to my on-premise application or my endpoint that's exposed on-premise. Another way that you can make a hybrid application is to use site-to-site VPN and routing and remote access service. Now, for this, you're going to need Windows Server 2012 with routing and remote access service on it. And basically what that does is it sets up a VPN between Azure VNet and your on-premise application. So if your SQL Server on-premise needs to get to something, or if your application on-premise needs to get to something in the cloud, it's routed through. Or likewise, if you're in the cloud and your cloud application has to get back to your on-premise application, it makes a call through the VPN gateway.
And it's important that RAS machine be an edge device. It can't sit behind a NAT or anything. It won't be able to connect.
That's correct. Yeah. Thank you. Now, one of the great features that we have in place today is called Express Routing. With Express Route, you get a very high energy pipe that goes between your application and Microsoft's Azure. So for that you have to go to AT&T or one of the other vendors that has Express Route and set that up. And at that point, it will allow routing between you, and so it looks as a private VPN between your application on-premise and Azure off-premise. Designing a media solution. If you haven't worked with media services, at some point in your career you probably will. Let's talk about what media services lifecycle is like. When we think of media services, the first thing you think of is, well, how do I go through and get or capture the video stream that I want? How do I encode that to ensure that it has the proper size and dimensions? Do I need format conversions from it? How do I protect my content through DRM? Do I allow on-demand streaming such that it's stored? Or do I go back to live streaming where I actually can stream things live? Do I get analytics off that? And mostly, how do I advertise? And with media services, it's very simple to get something up and running. Let's start down at the bottom of this and kind of walk through a workflow. So at the bottom of this particular slide, you can see I might create a some kind of media request. It's either on-demand media or I'm streaming something live. Now, in both cases, I have to go through media processing in order to get it to occur. The exam won't ask specific questions on media processing, at least that doesn't today, but it may ask capabilities. Once it's gone through both encoding and packaging, it's hosted. Now it can be gotten to through just a common CDN. From that, you can get analytics, and you can also, from the packaging, you can also set up particular advertising that you might want to do. So the workflow looks something like this. The client application either creates or gets a stream. It loads to Blobs storage, or it may in fact go directly into the REST API for media services. At that point, I schedule it. It might do things like encode, transmux, or encrypt, and I might also attach DRM to that. Now, DRM is going to allow me to protect that at the client end.
Is there any support for transcription of the audio content?
It does. So audio content is done exactly the same way, but you may not have the same encoders if it's just audio. Different codecs. One of the great features that's included is the Mavis Architecture. While you may not know the architecture Mavis, what you will know is that speech recognition. So some of the really cool things that Azure can do today is you can pass a content file that's encoded, and it can go through the file, pick out words and keywords, and index them. That's called the indexer. Now we've had a lot of different applications for this. In some cases, it may be live. So you might be speaking with somebody. You can use the REST API, pass that voice on to the Mavis, the Azure service, and it can reply to you, and you can translate that once it's transfixed. So there's a lot of different applications. For the exam, what you need to know is what an indexer is and what it does. And that's it for this module.